Hi, my name is Julia Woodward. I'm a first-year PhD student from the University of Florida. Today we'll be talking about using co-design to examine how children conceptualize intelligent interfaces. I did this work while I was an undergrad with Dr. Lisa Anthony from UF, as well as Dr. Jason Yet from University of Washington. Children are increasingly being presented with technologies such as intelligent user interfaces, or IUIs, that use modalities such as speech, gesture, or writing. For example, having the ability to handwrite on a tablet. But as previous research has shown, children's interaction behaviors and expectations are different from adults. And IUIs can really pose challenges to children due to their developing cognitive and motor skills. Just to define a couple of terms that I'll use throughout the talk. We define IUIs as a system that tries to interpret the user's intent, and an error as a mismatch between the user's intent and the system's understanding, such as Siri recognizing Intel as hotel. We focus error detection on determining the mismatch in expectations, whether it be from the user or the system, as well as error correction fixing the discrepancy in expectations. A lot of prior work has focused on making technology more usable for children. Prior work has mainly, though, looked at improving recognition and accuracy. In our previous work, we have examined children's gestures and highlighted features that can be used for recognition algorithms, as well as looking at how interface complexity affects children's touch and gesture interactions. While these approaches are effective in analyzing children's interactions to reduce errors that do occur, they don't look at children's expectations that could help decrease the impact of errors that occur. To look at children's expectations, we developed a conceptual model about children's understanding of IUIs. Recognition will never be 100% accurate, so we aim to understand how to limit the impact of errors that do occur for children. We use participatory design to develop this conceptual model. Participatory design focuses on bringing users and designers together, and we use cooperative inquiry, which looks at close partnerships with children. Prior work has used interviews to develop conceptual models, but interviews can be really challenging to children due to trouble verbalizing their mental models or fatigue or power dynamics. And participatory design has really been shown to elicit rich data, so we wanted to apply that in building a conceptual model for children. For our main findings, we showed that children really conceptualize IUIs, or intelligent user interfaces, as advanced whole systems. They didn't just look at user input or system output. They considered the context of interactions and user and system behavior. And they really expected advanced system intelligence. When examining error detection and correction, we really saw that children thought IUIs should be conversational and respond in a conversational manner and seek clarification from the user. And we were really able to apply participatory design in building this conceptual model. So we did this with Kids Team UW, which is an intergenerational co-design group from the University of Washington. It includes 7 children ages 7 to 12 and 11 adults that included undergraduate students, graduate students, and 1 professor. So we designed 4 sessions to scaffold the children's thought processes on IUIs with an emphasis on error detection and correction. For day 1, we focused on a handwriting game. We asked the groups to design a touchscreen game that supports handwriting. The only design constraint they had was that it had to include handwriting. Everything else was open to them. We used 2 participatory design techniques called bags of stuff and big paper. Bags of stuff is just a bag full of craft materials such as construction paper and glue, and the big paper is just used for them to collaborate together. On the second day, we focused on speech agents. The groups used and evaluated 4 different speech agents, including Siri, Alexa, Cortana, and Google Assistant. And we used the participatory design technique called stickies, where they would just write down likes, dislikes, or design ideas while interacting with these systems. For day 3, we started to focus more into error detection and correction. For day 3, we focused on user-initiated error correction, where we asked them to design ways a user could initiate and respond to errors, such as how would you tell the system there was an error, and how would you correct it. And we used the same participatory design techniques as day 1 with bags of stuff and big paper. For day 4, we looked at system-initiated error correction. So we asked the groups to act out how the system could initiate and respond to errors. So we actually had the children act out as a system, and the adults in the groups were the users while designing together. So we did analysis of this data. We transcribed the video recordings of each session. We had 279 minutes of video data and 308 child utterances. We used affinity diagramming to really analyze this data. Affinity diagramming is a bottom-up inductive approach. We iteratively grouped each transcription into different themes. So we identified 7 main themes across all of the design sessions, which we grouped into this conceptual model. We saw that the children really conceptualized IUIs as whole systems with advanced system intelligence, such as understanding context and having the ability to maintain a conversation and respond to emotion. They didn't just look at user input and system output when designing. So now I'll go into the themes individually and talk about how we really grouped this into a conceptual model. So the first main theme we saw was user behavior. In the children's mental model, we saw that intelligent system must learn from the user, that the user can take on a constructive role when looking at error detection and correction. A 9-year-old boy from design session 3, when we looked at user-initiated errors, said, show a picture of how it actually should be, show how to make it right. So he was talking about providing images to the system to show that there was an error and teaching the system how to respond to that error. We also saw that the children frequently challenged the system, and they expected a really high level of intelligence. A 9-year-old boy from design session 2, when they were interacting with the speech agents, asked one of them, when is the next time you will understand what I'm saying? They really wanted to challenge the system. So the next main theme we saw was user input. We saw that the children really expected a high level of system flexibility and that the system should support a wide range of modalities. The most common modalities was speech, handwriting, and drawing, but that's most likely due to our design sessions, such as the handwriting game. But we also saw them include hardware, such as pins and gavels, and wearables like smart bracelets into their design, such as creating a bracelet to change the text color. So we connected user behavior and user input together because we saw that children used input to demonstrate their own intentions to the system, such as being able to teach the system through images. So the next main theme we saw was system intelligence. The children really expected an advanced level of intelligence. In the children's designs, the system accurately recognized the user's input and intentions and responded in an intelligent way with conversation and emotion. For example, in design session 4, one of the adults as a user said, show me sushi, and one of the a child, a 10-year-old girl, said, as the system, this, or this. So really providing different options and showing the system's ability to make different decisions. We also saw another theme that is that the system should be conversational. An adult as a user in design session 4 said, I like pizza. And the child as a system said, which is your favorite pizza place? They really wanted it to be conversational and not very command-based. Another interesting sub-theme that we saw was meta-intelligence. In the children's designs, the system should be aware when it's confused and doesn't understand the user. And they even said, I don't understand as the system, or I didn't understand that. So we connected user input and system intelligence together because user input was related to the level of intelligence that the children expected to see. For example, for the system to understand speech, handwriting, and other forms of input such as gaze and emotion. So the next main theme we saw was user context. The children really incorporated the context of the interaction in their designs. For example, the children considered the age and gender of the user while designing. A 10-year-old girl from design session 1 with the handwriting game said, this pen is for toddlers because they don't have a good grip. They were really considering the ability of the user when designing these hardware materials. We also saw that the children expected the system to understand the social context of the interaction. A 9-year-old girl from Design Session 1 said if you write something special in the text, like happy birthday, it'll send some sparks flying or something. So really having the system understand the social context of happy birthday. So we link system intelligence to user context together because we saw that the system should react to the context of the interaction and the user, such as the user's age or ability with toddlers with pens because they don't have a good grip. The next theme we saw was system context. The children really emphasized certain domains into their designs. We saw that the children considered content for a base of their design. We saw children design like science games or games with fighting aliens and painting games. So they really used content for a base of their designs. We also saw that children designed ways to use hardware to provide feedback and interact with the system, such as using a gavel to tap once for yes or 2 for no. We also saw this theme of social interactions. The children wanted to communicate with their friends, like a social app, but also communicate to the system as a friend. For example, the girl in the picture designed a plushie in the handwriting game, and she said, it's like a pet and a little friend. It talks to you and asks to play a game. So really having this social ability with the system. So we saw a connection between system intelligence and system context because the children assumed certain system contexts and domains would be supported by the system, such as the ability for hardware interactions. The next main theme we saw was system output. The children really interpreted the intelligence of the system through its output. Speech was the most common output, most likely due to our design sessions, but they also included visual animations, colors, characters, and even physical items as output, such as using pom-poms to convey emotion when writing their name. So we connected system output to system intelligence because the children interpreted the intelligence of the system through the system's output, such as the ability for speech. And finally, the last theme we saw was system behavior. The children really expected human-like behavior from the system, that the system should be able to respond with appropriate emotion. We saw this theme of indirect response in their designs. As an example from Design Session 4, the adult as a user said, "What should I do tomorrow?" And the child as the system said, "You can go to a new place." "What new place? Why don't you choose?" So really this ability as the system to not directly answer the user and even give some sarcasm. Also, the children incorporated visual facial features into their designs, really showing that they expect these human-like characteristics. So we connected system behavior to system output because we saw that the children used output to make inferences about the system's behavior and intentions. And finally, we saw the cyclical connection between system behavior and user behavior because user behavior then influenced system behavior then influenced user behavior. So we compared our conceptual model to existing systems. Past design recommendations have helped decrease errors, but they haven't really considered children's expectations of what should happen when an error does occur. So based on our conceptual model, we saw that children really expected competent level of recognition. And when looking at error detection and correction, IUIs should really be conversational, admit when it doesn't understand, and seek clarification. This is really interesting because it goes against existing techniques such as autocorrection, which just tries to do it in the background. But the children really wanted the system to say, like, "I don't understand." We also saw that the user can take on a very constructive role when looking at error detection and correction in the children's designs, such as teaching the system through images. So we came up with a couple of design recommendations when looking at error detection and correction. For example, the IUI should maintain a conversation, and designers can include conversational prompts into their designs to gain insight into the user's intention. As well, the IUI should seek clarification from the user, admit when it doesn't understand, and ask the child to rephrase. So overall, we saw that children really conceptualized IUIs as advanced whole systems. They included the context of the interaction, as well as user behavior and system behavior into their designs. When looking at errors, IUIs should be very conversational and seek clarification. And we were really able to use participatory design to elicit this rich data and build this conceptual model for children. So by integrating our work with how children conceptualize intelligent user interfaces with previous work that has looked at improving recognition and accuracy, we can really build these systems to meet children's expectations and help reduce the impact of errors that do occur. Thank you. And thank you for coming to the last talk of Kai.
Thank you very much, Julia. So again, if we have questions, that keeps cutting out still, doesn't it? Please do come down to the front where there's a microphone.
Hi, Arti Mano from Northumbria University, Newcastle. It's a really interesting project. I was wondering if you could say a little bit about what was your kind of key value in using co-design as a method, especially with children?
I'm sorry, I didn't hear you.
What was the key value in using co-design, especially when working with children?
Okay. Definitely. So prior work has really used interviews to build conceptual models. But prior work has also shown that interviews can be really challenging to children. They really have trouble in interviews such as like the power dynamics and everything. Yeah. So using participatory design or co-design really helped us really get into their conceptual model. Even in the work, while doing the co-design sessions, we actually asked them a couple of questions, like how would you define an intelligent system? And doing those interview questions, some of the children even said like smart or cool. So that's not really showing their conceptual model of the system. So by doing these design techniques, we were really able to understand what they expect from these systems and see how would they design it and what they expect when interacting with them.
I have a question as well, and I think it sort of leads on from what Arti was saying there. I kind of really like the fact that you were building these co-design workshops over time, so there was a temporal element to it, so you had them on different days, etc., etc. And I was just wondering, because the subject matter you were trying to engage the kids in is quite difficult to get your head around in terms of these intelligent interfaces, was that staging of the activities over time important? I.e., you could have just given them an Alexa or a Siri device right from day one and got them to play around with that. But how did you kind of frame those or configure those sessions carefully?
Sure.
Was that an important consideration that you had going
Sure.
into the design of those sessions?
Okay. So Kids Team actually meets Tuesdays and Thursdays every week. So we did Tuesday, Thursday, then Tuesday, Thursday, just to give you an idea of how spread out the sessions were. So when looking at building, we designed the sessions to really scaffold their thought processes because it's a really, like you're saying, complex thing to think about. Like if we have jumped into like system-initiated error correction, it would really kind of have confused the children. We might not have seen the data that we got. So we really wanted to spread it out and more like introduce the concepts, such as doing the handwriting game, just thinking about different modalities, then interacting with existing systems, and then really delve deep into the error detection and correction. So I think it was important to spread them out a little bit with the Tuesday, Thursday, as well as scaffold them in that process, because it would have been really challenging for the children to think about, error detection and correction without really the context of intelligent systems.
And were you looking back at the previous sessions? Were they building on each other as well? So in the beginning of one workshop, did you look back to see what was discussed before? Or was it new activities each time?
So we did look at the design sessions as a whole and when designing. And we looked at all of them together, but really looked at each one separately too to see what each session gave to the conceptual model. So the beginning ones really gave like user input, system output, but design session like 3 and 4 with the user-initiated error correction and detection, the system-initiated, really helped us get deep into the data. And we saw that design session 4, when they were actually acting out of the system, gave us the most rich data compared to just doing like bags of stuff and big paper.
Hi, thank you for your talk. I'm Sarthak from HP Labs. So I was wondering because I've seen that my nephews and nieces are already very much like familiar with using apps and iPads and everything. So I was wondering, did any of the children mention existing intelligent UIs or existing apps while they were designing their new ideas, and whether that affects your design in any way? Basically your research.
Right. So these children were from Seattle, so some of them did, like they mentioned, some of them had Alexas at home, because their parents had it. A lot of them have already interacted with touchscreen phones, just because nowadays it's really hard to find children, that don't have any experience with technology. So we saw that it might have influenced their designs just because they had interacted with these technologies more. And we really view this conceptual model as a starting point. We really want to apply it to different contexts and see with children at different economic and social statuses, because we really view this as a starting point. And like you mentioned, like some of the children did have prior experience with technology, even though nowadays it's, kind of hard to find children who have none, because like you said, like I've seen really young children know how to use technology a lot better than I do.
So, did you see any influence of the apps they use on their mental models?
I think it did affect some, just by including, like speech or handwriting into their designs. But they also thought about it like in different ways, going past that. Like I said, they really expected IUIs to be very conversational and admit when it doesn't understand and be more like a human-like behavior, which is really goes against existing techniques like autocorrection and technology now. So it's really, they do apply what they see in technology now into their mental models, but they really go past that as well.
Thanks.
You're welcome. Thanks.
Okay, so I think we'll leave it there. So one final round of applause for Julia and for all of our speakers for this closing session. So just to remind you all that we have the closing plenary with Sue Gardner's closing talk, which will be in the main plenary room in 20 minutes, but there should be some last bits of coffee outside for us all. Thank you.